Okay, welcome to section one of today's conference. So, we'll be treating physics, specifically wave. Now, the very first section or the very first topic of wave that we'll be treating is introduction to wave. Now, when you hear the word wave, when you hear the word wave, what does it mean? Now, take note, a wave is just, please, before I start, please make sure you have a book then and a pen so that you can use to jot important points. Now, what is a wave? A wave is what? Is a disturbance. A wave is a disturbance. What is a wave? A wave is a disturbance that travels through a medium. A wave is a disturbance that travels through a medium. A wave is a disturbance that travels through a medium, transferring energy from one point of that medium to another. Now, the important thing you need to take note of under wave is that one, wave travels through a medium. Yes, that is one of the important things you need to take note of. Wave travels through a medium. Then the other important thing you need to take note of is that it transfers energy. It transfers energy. So if they ask you define wave, wave is a disturbance that travels through a medium, transferring energy from one point of the medium to another point. That is the definition of wave. The classification of wave. Now take note that there are different classes of wave. We have one mechanical wave, we have two electromagnetic wave, three progressive wave, four standing or stationary wave, five transverse wave, while six longitudinal wave. Now let me explain these two first. Now, what is a mechanical wave and what do you understand by mechanical wave? Mechanical wave, these are just waves that require material medium for their propagation. Wave that require material medium for their propagation are known as what? Mechanical wave. Now, example of this wave, water wave and what? Sound wave. Sound wave and water wave are examples of mechanical wave because they require material medium for their propagation. Now, take note that without water wave can never be propagated. Without air, without solid, without liquid, sound wave can never be propagated. Now we move to electromagnetic wave. What do you understand by electromagnetic wave? Electromagnetic wave are opposite to mechanical wave. If mechanical wave require material medium for their propagation, electromagnetic wave, they don't require material medium for their propagation. They travel through a vacuum. Electromagnetic wave, they travel through a vacuum. They don't require material medium for their propagation. Examples of this wave are called the Gaussian line. Gaussian line is an acronym used for the examples of this wave. The GA stands for gamma ray. The GA stands for gamma ray. Then the X stands for X-ray. The U stands for UV ray. The L stands for light wave. I stand for infrared wave, while R, the last, stand for radio wave. So these are all examples of electromagnetic wave. They don't require material medium for their propagation. They travel through a vacuum and they also travel at the speed of light. Examples are called what? The Gaussian line. You can use these mnemonics or you can use these acronyms to remember the examples of this wave. The GA stand for gamma ray, X stand for X-ray, U stand for UV ray, L stand for light wave, I stand for infrared wave, while R stand for radio wave. Okay, then we move to the other classes of wave. The other classification of wave is progressive wave, stationary or standing wave. Now, where is a progressive wave? A progressive wave, these are wave that spread that. These are wave that spread that they have no restriction. Example of a progressive wave is a water wave. Water wave is an example of a progressive wave. The important thing to need to take note of under progressive wave is that progressive wave they spread out, transferring energy from one point to another, and they have no restriction. The opposite of progressive wave is stationary or standing wave. Stationary or standing wave, these are waves that they don't spread out, they are restricted. Now they are produced when a progressive wave now they are produced when a progressive wave of equal energy is reflected. When a progressive wave of equal energy is reflected. When a progressive wave of equal energy, amplitude, frequency, wavelength is reflected. Okay. So these are stationary wave is. These are stationary wave is. Stationary wave, they are waves that have restriction. They are produced when progressive wave of equal energy is reflected from a surface. And take note that this wave they don't transfer energy. This wave don't transfer energy. Stationary or standing wave they don't transfer energy. And also take note that these are waves that have node and antinode. Standing or stationary or standing wave, they are waves that don't transfer energy, and also they are waves that have node and antinode. Now where is a node and where is an antinode? Now this point you usually see here is known as the node. The point you usually see here is known as what? The node. While this side is known as the antinode. Okay, this point is known as the node, while this side is known as the antinode. Now, where is node? Node is a point. Node is a point in a stationary wave where there is no displacement of particle. So, node is a point in a stationary wave when there is no displacement, whereas antinode is a point in a stationary wave where there is maximum displace maximum displacement. Now, the important thing to take note of under this classification of wave is that progressive wave they spread out in all direction, transferring energy. They don't have restriction. Example of a progressive wave is water wave. Then stationary or standing wave. Stationary is also called standing wave. Is an opposite of progressive wave. They are produced when a progressive wave when a progressive wave of equal energy, amplitude, frequency is reflected from a surface. And take note that stationary or standing waves they don't transfer energy. They are waves that have node and antinode. And what is a node? A node is a point in a stationary wave where there is no displacement of particle. Whereas an antinode is a point in a stationary wave where there is maximum displacement of particles. Another classification of wave is transverse wave and longitudinal wave. Now let me first talk about what is transverse wave. What is transverse wave? Now a transverse wave is a wave in which the direction of motion is perpendicular. A transverse wave is a wave in which the direction of the motion of the wave is perpendicular to the direction of the particles. Now, this is the direction of the wave motion. This is where the wave, this direction in which the wave is going, whereas this is direction of the particle. Now, these are all the particles that makes up the medium. They are moving in this direction. Whereas the direction of the motion of the wave is in this direction. Now, if you look at this is the direction of the particle, while this is the direction while this line is the direction of the motion of the wave. If you look at these two lines, they are what? They are perpendicular to each other. So take note that transverse wave, these are wave in which the direction is where this direction of the motion, in which direction of the motion of the wave is perpendicular to the direction of the particles that makes up the medium. The particles, they are moving in this direction, whereas the direction of the wave is in this direction. Particle direction is like this, then the direction of the motion is like this. So what are the examples of transverse wave? Water is an example of transverse wave. Wave in a pipe. Wave in a pipe is an example of a transverse wave. And also take note that the electromagnetic wave, all of the electromagnetic wave, the gamma ray, the X-ray, the UV ray, light wave, infrared wave, radio wave, they are all examples of what transverse wave. The direction of the particles in those waves is usually perpendicular to the direction of the motion in those waves. And also take note that wave in a string, when it's okay, the wave in a string, when a string is fixed at two ends, when a string is fixed at two ends, the wave in that string is a transverse wave. But when that string is just only fixed in one end, the wave in that string is no longer a transverse wave. Okay, so the important thing you need to take note of under transverse wave is that a transverse wave, the direction of the motion of the wave is perpendicular to the direction of the motion of the particle. Examples of transverse wave are water wave, wave in a pipe, electromagnetic waves such as gamma ray, X-ray, UV ray, infrared ray, light wave, etc. Then also wave in a string that is fixed at both ends. The last classification of wave is longitudinal wave. Longitudinal wave is opposite to transverse wave. Remember, in transverse wave, the direction of the wave motion is perpendicular to the direction of the particle. But in longitudinal wave, it's the opposite. Look at it. This first waveform is a wave in a string fixed at one end. If you can recall, I told you guys that when a string is fixed at both ends, what the wave produced when the string is vibrating is a transverse wave. But when a string is just fixed at one end, the wave produced in that string is a longitudinal wave. So this is the wave in a string. I placed two waveform in this. I placed two waveform here. This is a wave in a string, and this is sound wave. Okay, this is sound wave, while this is wave in a string fixed at one end. Now, what is a longitudinal wave? A longitudinal wave is a wave in which the direction of the wave is parallel. In which the direction of the wave is parallel to the direction of the particle. In which direction of the motion of the wave is parallel to the direction of the motion of the particle. Now, if you look at this diagram very well, you find out that this is a person's hand, and this is where the string is fixed. Now, this is the direction of the wave. If you are these are the direction of the wave is in this direction. Imagine you pressing on a string. If you look at this place, this part of the string is compressed, while this part of the string is not compressed. This part of the string is compressed. The other part of the string is not compressed. So it is in this direction. This direction of the wave. It is in this direction. Whereas this is also the direction of the particle. The particle direction is also in this direction. The direction of the wave is also in this direction. So the two lines, they are what? The two lines, they are parallel. So this will tell you that a longitudinal wave is a wave in which direction of the motion of the wave is parallel to the direction of the motion of the particle. Example of a longitudinal wave is a wave in a string fixed at one end, and also sound wave. Sound wave is also an example of longitudinal wave. Now, this is the waveform of sound wave. If you look at this place, the air is compressed. in this point the air is not compressed. At this point the air is compressed. Now this is the direction of the wave. This direction of the wave, and also this direction of the particle. So if you look at it very well, the two directions, they are what? Parallel. Okay, so this will tell you that in longitudinal wave, the direction of the wave motion is parallel to the direction of the particles of to the direction of the particles that makes up the medium. Okay, so longitudinal wave is a wave in which direction of the motion is parallel to the direction of the motion of the particle. An example of a longitudinal wave is sound wave, wave in a string fixed at one end. Now please take note of this. Water wave, water wave is also a longitudinal wave. Take note that water wave is the only wave that is both a transverse wave and a longitudinal wave. If you look at the previous, if you look at under transverse wave, I told you guys that electromagnetic wave, water wave, wave in a pipe, and wave in a string fixed at both ends, they are examples of transverse wave. Now, under longitudinal wave, water wave is also an example of a longitudinal wave. Take note that water wave is the only wave that is both a longitudinal wave and a transverse wave. Okay, so in summary, longitudinal wave is a wave in which direction of the motion of the wave is parallel to the direction of the particle. So the two directions are in the direction of the direction are usually in this side, and they are what? Parallel. Sound wave, please take note, sound wave is an example of a longitudinal wave. Okay, whereas light, X-ray, gamma ray, they are all examples of transverse wave.